This is Algebra 2 with Trig, working on Chapter 13. This is the review for law of sines and law of cosines, 13.5 through 13.6. We're looking at number 1, where we're going to solve this triangle. So when we're thinking about law of sines, we need to have two letters or two sets of numbers for the same letter. So angle C, this is side C. Angle B, side B. This is side A. I need to know what angle A is. Well, I can get angle A by taking 180, subtracting 71, subtracting 28, and coming up with 81 degrees for the measure of angle A. So if that's 81, I can now use law of sines, A over sine of A, and let's solve for side B. B over sine of B. So we're going to have 15 over the sine of 81. That equals B over the sine of 28. So we'll cross multiply and get 15 times the sine of 28 over the sine of 81. That's what B equals. So B is going to come out to be 7.13. So now, if that's 7.13, those are the two values I've solved for. I have one more to solve for. Let's use B again over the sine of B. No, I'm going to take that back. We're going to use A. A over the sine of A equals C over the sine of C. Now I decided to use A because A was the two numbers that they gave us. 81 was pretty simple for us to calculate. I didn't want to use a rounded number like 7.13 for the B value, so I wanted to stay away from using B. So 15 over the sine of 81 equals C over the sine of 71. Cross multiply, and that equals our C, and that'll come out to be 14.36. So here we have solved our triangle ABC for all the missing information. Number 2. Here they give us an angle, a side, and a side. So with angle, side, and a side, you do need to be careful with what information that they give you. If we turn this a little bit, so it's more like our notes, this is our angle A, the side opposite is A, and the other side is 28. That opposite side is greater than this, so we know that there's one obtuse triangle. This is a side-side angle, so this is going to have one obtuse triangle because A is bigger than the other. A is larger than B in this case. Here originally they showed us angle, side, angle, so we didn't have to worry about how many triangles there were or if it's obtuse or acute. Angle, side, angle, we just solve for the missing angle, and then you can solve for the sides. Here, this is part of that ambiguous case that we do have to be a little careful. If you didn't think about it, you would be completely fine, because we're just going to solve for it anyway. But this does fall underneath that scenario. So we have A over the sine of A. That's the information we have from the same letter. We have the side for A, we have the angle for A. B sine of B. What we don't have is angle B. So when we plug in the numbers, we have to solve for the sine of B. And to do that, we're going to divide by 42. So the sine of B is going to equal 0.5714. Then we take the inverse of that 5714, or even better if you use the ANS button, the answer button on your calculator, and you'll come up with 34.85. That's the measure of angle B. So it looks like the directions are actually asking for to the nearest degree. That would round up to 35, but usually we like to be a little bit more exact. So I'm going to leave it exact, or at least rounded to the nearest hundredth. Okay, so now if we're looking for angle C, B was 34.85. C is going to be 180 minus the 121. So that would be 59 minus the 34.85. So angle C is going to come out to be 24.15. And then to solve for C, we're of course going to use the ratio that has C in it, and then we're going to use the ratio with the information that they give us, which is A. So C over the sine of 24.15 equals A over the sine of 121. Well, A itself, I guess, you don't need to put an A in there. We can put a 42. We'd cross multiply, so that C is going to be 42 times the sine of 24.15 over the sine of 121. And that'll come out to be approximately 20.05. Here we're going to solve they're giving us the pointers that we need to use the flow chart to help determine how many triangles. Here they're giving us 2 angles and a side. So if we draw our picture out, we know that angle A is obtuse. That's 95. They're giving us another side and angle. So this would be side A because it's across from angle A. This would be side B because it's across from angle B. Okay, they're giving us an angle side. If they give us angle side, we don't have to worry about how many triangles there are. There's one triangle and we move forward. The only time we have to consider the number of triangles is if we're working with a side angle. So we're going to take 180, subtract the 95, subtract the 35, and that's going to give us 50. So that's going to be the measure of angle B. So B is 50. Now we have all the angles. Now we're looking for 2 different sides. We know that we have the information for C, so we're going to use the ratio with C. And then now we can find the ratio for A. C is 18 over the sine of 35. We don't know side A, but angle A is 95. So if we want to get A by itself, we're going to cross multiply just one direction. So we can use our calculator and figure out that A is 31/26. So now we need to find side B. Side B, of course, we're going to use the ratio with B. And then we'll use the ratio of the numbers that they give us. So we're looking for side B, but we know angle B. We know side C and angle C. We'll cross multiply. So we know that B is going to equal 24/04. In this case, here we see that they give us another obtuse angle. The side opposite they give us is A is 11, and the other side they give us is 13. Now notice here that they give us this angle side, or we like to call it side angle. Remember, with scenarios of side angle, we do have the chart that we follow to verify how many triangles that we have. So looking at our notes say that if we're dealing with side-side angle and we have an obtuse triangle, if that opposite side is smaller than the adjacent side, then of course it's not going to reach the other side. It's going to give us no triangle. We can swing this around and it's never going to touch that opposite side. So if the opposite side is too short when given an obtuse angle for side-side angle, then we have no triangle. Well, we look at this and we see that A is less than side B. Okay? We have an obtuse angle, so we have no triangle. The opposite side is smaller than the adjacent side. If given side-side angle and an obtuse angle, if the opposite side, in this case that would be side A, is less than or equal to the other side, B in this case would be considered our other side, then those values could not make a triangle. We like to use the word opposite and other, or opposite and adjacent, when dealing with this, because if you always use A and B and they don't give you those letters, if the angle is not considered angle A, then the side opposite is not side A. So that's not always the best representation to use. You do need to be familiar with the opposite and the other side, or opposite and the adjacent side. Anyway, there's no triangle with those numbers. Let's look at what they give us here. Okay, they're going to give us a small angle, which is 10, another relatively small angle, which is 23, and then angle A. Side A is 15. So notice that they're giving us an angle side angle. Since they gave us angle side angle, we don't have to worry about how many triangles there are. We only worry about that with side side angle. So no need to look at the chart from our notes. So we're going to start out with trying to find that missing angle for angle A. We're going to minus 23, we're going to minus 10, so we're going to get 147. That's the measurement of angle A. So now we're looking for side C and also for side B. We're given both bits of information for A. So I like to start out my law of sines with the letters to help me identify exactly what I'll be looking for. Then I plug in my numbers. cross multiply. And I've calculated now that B is going to be the value of 4.78. You want to be sure to use your calculator to see if you can get these values. Then I'm going to look for the other side. Looking for side C. If side B is 4.78, so I plug in my numbers. A is 15, sine of 147. We're looking for side C if angle C is 23. So using our calculator, we should come up with 10.76. So that solves for all three angles and all three sides. Here, let's draw our triangle out. They give us an angle. Angle C is 49. Side C is 19. Side A is 24. I would suggest to put them in this order so it follows our notes. Notice what they've given us. They've given us an angle side side. We often write it down as side side angle. Okay, this is with an acute angle. An acute angle they're giving us. So if we look at our notes, we're going to look under the category of acute, and we notice that the opposite side is definitely smaller than the other side, so we don't have it longer than it. If it is not longer than the other side, we have to calculate what the height is. So since 19 is definitely smaller than 24, we need to calculate what this height is. We've got to see if it even makes a triangle. So if this height is more than 19, then we know that this won't even make a triangle. If it equals 19, then we know the triangle that's formed is a right triangle. So to calculate this, we're going to use the sine of C, which is 49, equals this height over the hypotenuse for this smaller right triangle, which is 24. So we're now going to say 24 times the sine of 49 equals our h. And when we do that, we're going to find out that we get 18.11. That's telling us that our opposite side is actually longer than the height. If it's longer than the height but shorter than the other side, we're going to come into two triangles. So this really comes all the way down on that side, so that's one of our triangles. Or you could say that it comes down to this side and makes this obtuse angle with the 49. So I'll sometimes shade that one in just so we know what we're talking about, we have two triangles. We have this larger triangle, or we have this obtuse triangle. We have the larger triangle where C equals 19, angle C is 49, side A is 24. We need to find angle A, angle B, and side B. Well, we also have the shaded triangle, and that shaded triangle has that obtuse angle, has 49 degrees in this corner. That obtuse angle still has 19 for the side of C and 24 for the side of A. Angle A is obtuse, angle B, and side B. So we have these two triangles to work with. Let's start out with this one. Even if you didn't notice that this was side-side angle and you just took the numbers and started to solve, this is the triangle that you would be solving for. If you don't recognize what's happening, then you're never going to recognize the second triangle. But you can still work this one out. So, we're given C and angle C. We're given A. We can now solve for angle A. 19 over the sine of 49 equals 24 over the sine of angle A. We'll cross multiply to get 19 times the sine of A, which equals 24 times the sine of 49. We're going to divide by 19. So our sine of A is going to equal 0.9533. So when we do sine inverse of 0.9533, we should get 72.42, which is the measurement of angle A. $72.42. Now to find angle B, so before I write that here, I'm going to say that with SSA, since the opposite side is greater than the height, but less than the other side, less than 24, we have two triangles. So we're going to take 180 and we're going to subtract the 49 and we're going to subtract the 72.42. When we subtract those values out, we're going to come up with 58, 58. That equals the measure of angle B. And then we have this last side to solve for. So I'm going to shorten it up and just plug in some numbers. 19 sine of 49 equals B over the sine of 58, 58. Cross multiply. We find out that this side B comes out to equal 21/48. So those are the missing parts to our first acute triangle. Okay, now we're going to be working with this triangle. Well, the trick here is that angle A on this side was 72. So the angle A on this side is 180 minus 72.42. That comes out to 107.58. And once we figure out 107.58, then we can find out angle B by saying 180 minus the original 49 minus the 107.58 that's going to equal our last angle of 23.42. So now we have the two missing angles. Notice how quick we can solve for this missing triangle, this obtuse triangle, this second triangle of our side-side angle. Now, the only thing we have to solve for now is side B. So we're looking for side B. If angle A is 23.42, we're given 19 over the sine of 49. We're going to cross multiply to get 19 times the sine of 23.42 over the sine of 49. And using our calculator, we would come up with 10.006. Now that's pretty detailed there, 10.006. I just didn't want to call it 10.0. So that's our missing side over here. So there's an example of two triangles and finding all the missing parts to those triangles. First we had this acute triangle. If you do nothing but use the numbers, those are the numbers you're going to get with the values. It's the second triangle that's a little bit tricky. You need to take your angle that you had found over here, this acute angle, subtract it from 180 to figure out its pair, what the obtuse angle is for your other triangle. Then you can subtract the two angles from 180 to figure out the third angle, and use law of sines to figure out the final side.